All right, today we want to talk about logarithms. So let's say we started with talking about a chart of, in this case, I have a fly, a cat, an elephant. And let's say we're going to talk their weight, how much they weigh. So the fly, like let's say here's 1 pound. The fly might be like really low there. It's not even a pound. A cat might be way up here at 12 pounds. Okay, big heavy cat. An elephant, well, that's way off there. I can't even plot it, can I? So what happens sometimes when we're plotting things, maybe we're plotting the distance away from the sun, the different stars or whatever, the difference between them is so large, trying to graph it makes no sense. So what we do is we shrink down that graph. And what we do is we put in a log graph, a logarithmic graph. And you have a 1 here and a 2 here and a 3 and a 4. But what do those stand for? Well, what they're standing for is 10 to the first, 10 to the second, 10 to the third, 10 to the fourth. We're using that 1, 2, and 3 are the exponents. Now think about it. 10 to the first is 10. 10 to the second is 100. So even though they're evenly spaced, that's 100. And the next guy, 10 to the third, is 1,000. And this next guy up is 10,000. So we have to graph these guys because, again, the numbers vary so widely. We put them in a log graph. And we have to deal with that with a lot of things. Believe it or not, one of them, and I'm sure you didn't know this, is the Richter scale. Now, do you remember from your earth science days what a Richter scale is? It's measuring earthquakes, the strength. So when they say, hey, it had a 3 on the intensity scale, on the Richter scale, it measured a 3 today. Well, that literally means, hey, it was sort of like a 10 to the third. It had the shaking power of 1,000. And when they say, oh, it was a 4 today, well, that is 10 to the fourth. That is 10,000. Notice the difference between a 3 and a 4 on the Richter scale. That 4 is 10 times more powerful than that 3 was. So if somebody is talking a 6 versus an 8, well, that's 10 to the 6 versus 10 to the 8. This 8, that guy is 100 times more shaking power. It is way more devastating than a 6. So each time it goes up by a number in the Richter scale, it is extremely powerful. It's 10 times more powerful than the previous. Now, we also use it in other things. We use it in the pH scale. Maybe you do that in chemistry. Decibels in sound, we have that. Even light intensity is measured in a logarithmic scale. So we have these several things that are used just because the difference between them is so vast that we need to sort of shrink the scale down to make it more manageable or more easily understood. I mean, if they really came on the Richter scale, hey, today it had a shaking power of 143,212, it doesn't, it starts being a little difficult to understand. Now, if we look at these things, most logs we're talking base 10, but they can be in other bases. But let's say that we just look at a common exponent, 10 to the third equals 1,000. This is your base, right? That's always your base. This is your exponent, which is going to be our answer to a log problem. And then there's sort of our number. Well, how would we write this? So how would we write 10 to the third equals 1,000 if we wanted to write it as a log? Well, here's the way it'd be written. Log of 1,000 base 10 is equal to 3. That answer to the log problem is always the exponent. In this case, it's 10 to what power? If somebody says to me, hey, what's the log of 100? It's understood if you don't have a number there, if you don't have the base, that it is a 10. The log of 100 basically means, hey, 10 to what power gives you 100? That's going to be a 2. That's going to be a 2. So let's look at a couple problems here. So let's say they say log of 9 base 3. Well, to get the answer, we're simply in our brains thinking, hey, 3 to what power gives you 9? Well, that's 2. So the answer to that is 2. What about the log of 8 base 2? Well, that means base 2 to what power gives you 8? That's a 3. 2 to the third power gives you 8. Next one, a little bit harder. We have base 2. So 2 to what power gives us 32? Well, 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. The next one, Log of a fourth, base 2. So 2 to what power gives us an answer of a fourth? Well, I know 2 squared is 4, but I need the 4 to be in the bottom. How do you get it to be in the bottom? Negative exponent. Yes, it's going to be a negative 2. Remember, if we want to move it down, we can make it a negative. The next one, 5, log of 1, base 5. So that means 5 to what power equals 1? Any number to the 0 power is 1, except for 0, that's undefined. And then the final problem here, we have 7 to what power gives you 7? 7 to the first. Now, there's 2 more problems I want us just to approximate. We'll learn how to get the answer. I mean, we can just grab the calculator and type in log of 153 and it'll tell us the answer. But here, I want us to think log of 153 base 10 is equal to what? Well, let's think. 10 squared I know is 100. 10 to the third would be 1,000, which is way too much. So we know this answer is between 2 and 3, closer to that 100, closer to that 2. So I'm going to guess let's just go with 2.11. Honestly, I don't know the answer, but there's an approximate answer. And let's do one more. All right. Log of 1,824 base 10. Well, that means 10 to what power gives us that? Well, 10 squared is 100. 10 to the third is 1,000. We're still not there. 10 to the fourth would be way too much at 10,000. So it makes sense this answer is a little bit more than 3. And let's go with 3.2. Again, I don't know the answer. I could just go to the calculator and type in a log of 1,824. It'll always be set base 10 on your calculator, and it'll tell you what it is. So that's logs. Again, we use logarithms in a lot of things. Like I said, pH scales, decibels with our sound, the Richter scale, light intensity. We see them in a lot of things that we study. So this gives you a little touch for logarithms, and then we'll see how they're really used to help us solve math problems the next section.